we see examples of triangular numbers. So what does it essentially say? The following animation shows patterns in triangular numbers. So there is 1, 3, 6, and n into n plus 1 over 2. That's basically the equation of the nth term that we have. Nth term equation. So what are triangular numbers? I'll explain it to you. Have a look. Well, the explanation has been given below, but imagine that if I have a piece or of whatever it is, and then I have two pieces below it, and on the third line I have three pieces below it, and then I have four pieces below it, then I have five pieces below it. So these are examples of triangular numbers. So you see, the first three terms that were given were 1, 3, and 6, which means that on the first tier there was only one. On the second tier there were two, but if we were to add both of them together, that would give us an answer of 3. On the third tier there were three, but if we were to add all of them together, that would give us an answer of 6. So do you understand how this question is going around right now?
Yeah.
All right. So this is what it's essentially showing us. Have a look. The following animation shows patterns in triangular numbers. The media can listen audio. Okay. So there is a row number, and there are a number of triangles, U, up triangles. Okay. And then there are a number of down triangles, and then there is a number of total triangles. So have a look here. When there is the first row, in this case, so there is only one triangle and that's pointing upwards. But when we have the second row, we have one triangle that points upwards, then one that points downwards, then one that points upwards. So essentially, in the second row, we have a total number of, uh, only in the second row, we have a total number of two triangles. And in total, if we add cumulatively row 1 and row 2, we have a total number of how many triangles? Six triangles that point upwards. So all of this is basically accumulated figure. All right, you don't have to write this down right now. Just try to understand. This makes
All
sense?
right, just a minute. I'll be right back.
Sure, no worries. So these are this is basically what the animations are showing us. Below is an example of the up triangles and the down triangles. The table below is populated with some of the results. Write down the missing values in the table up to row 5. So for row number 4, we can see that the difference that we have essentially is, it can be written like this. Here the difference is of plus 2, here the difference is of plus 3, so here it should be of plus 4, and here it should be of plus 5, so on and so forth. So this is going to be 10 and this is going to be 15. And since the number of down triangles start from 0, so it's basically a value shift. It's a minor value shift. So 0, it's the difference of positive 1, positive 2, positive 3, positive 4. So it should be 10 here. The total number of triangles, they're all going to add up. 6 plus 3 is 9, 10 plus 6 is 16, and 5 plus 10 is 25. So we can clearly see an amazing pattern being followed. Does that make sense?
Yeah.
Okay. Describe in words three patterns you see in the table. So if it says three patterns, so we should talk about all of these three patterns: the number of up triangles, the number of down triangles, and the number of total number of triangles. Can you tell me, or like, can you guess what can be a pattern being followed in the total number of triangles? What can we see here about the total number of all triangles? What sort of pattern is being followed here? Any ideas? We can see that each and every number represented in this column is basically a square number. So for total triangles, I can say that it is equal to the square of row number. If anyone was to write t equals n squared, the answer would have been considered wrong. Reason being, what's the reason? The reason is that they are asking us in terms of words. Okay. Secondly, another pattern that we can see for the down triangles is that the number of down triangles in row n is basically equal to the number of up triangles in the previous row. So, number of down triangles, well, I can just write D is equal to number of up subtracted by 1 or subtracted by n. U subtracted by n. That's also a pattern. And we can also say that the number of up triangles, or basically U, it increases by adding the next row number each time. Alright, these are going to be three efficient ways, like a simple way to describe these three patterns, and that's going to give you the mark. After that, what do we have? Write down a general rule for t in terms of n. In terms of n, so that's pretty straightforward. We just found the answer previously, that was t equals n squared, right? So whatever the value of n we had, um, if we were to square that value, we would get a final answer of t. So that would be our correct answer. All right. Verify your general rule for t. We can verify the expression of t equals n square by adding the explicit expressions for u and d. So, okay, it's verify, not justify. My bad. I thought it said verify, justify. So that can be done by matching the values inside the table. So if you were to write 1 squared, you should get a final answer of 1. If you were to write 4 squared, you should get a final answer of 16. 5 squared, that gives you a final answer of 25. So you can write, hence, my values are verified since they are same as that in the table. This is how you're going to simply verify. That's pretty straightforward.
Alright, I wrote this down.
That's great. The following video shows a systematic method for counting triangles from a diagram. Okay, so when there is stage 1, we are essentially uh, shown that there are two triangles. No, stage 2, the number of triangles above the line A is basically 3. So this is triangle 1, this is triangle 2, and the sum of it is going to be 3 triangles. Okay, so that's what is being shown per stage. Investigate the values in the table to find a relationship for t in terms of n, and your answer, you should create more values and record these in the table below. Okay, let's do the prediction part first. So when there was the first stage, there was one triangle above. Then stage 2, there was 3 triangles. Then stage 3, there were 6 triangles. So the pattern is evident in front of us. Plus 2, plus 3, plus 4, plus 5, plus 6, so on and so forth. So this should be 15 and this should be 21. And the values are going to be same as they are here as well. Here it should be 10, here it will be 15, and here it will be 21. Same as well, right? Because it's basically a linear sum. And adding on the number of triangles that are crossing the line, 1, 2, 3, it should be 4, 5, and 6. And then if you had to find the total number of triangles, what we were supposed to do, we were supposed to just add all of these values together. So if you were to add these values together, so in the first column we had 3, the second column we had 3 plus 3 plus 2, which is 8, the third column was 15, the fourth column is supposed to be 24. Okay, here is another pattern being followed in T as well. We'll notice this. 15 plus 15 plus 5, that's 35. 21 plus 21 is 42. 42 plus 6 is going to be 48. So this is how we are done with the prediction of all values. Make sense? Let me just bring this down. Okay, there's no need essentially. So we're done with the prediction. Describe in words any patterns for columns C and T. Okay. Uh, as far as C is concerned, so I can say that the number of crossing triangles C is basically equal to the stage number. Number of C is equal to stage number. What about the pattern for column T? So we can see that as the value of n increases by 1, the total number of triangles increases by consecutive odd numbers. So 3 and 8 has a difference of positive 5. 8 and 15 has a difference of positive 7. 15 and 24 has a difference of positive 9, positive 11, and positive 13. So can we see an example of a quadratic sequence here in front of us? Because the first year difference is not same, but the difference of 5 and 7 is positive 2, right? So I can say that for t, as n increases by 1, total number of triangles increase by consecutive odd numbers. That is what is going to give you those marks. Alright? Write this down and tell me once you're done. As we move forward now, what does the next part say? Find a general rule for t in terms of n. Okay, so we are here supposed to find the general rule for t. Let's try to write each and everything down once again. We had 3, 8, 15, 24. Then we have a difference of positive 5, positive 7, positive 9, positive 11. And here we have a difference of positive 2, positive 2, and positive 2. So how can we solve this question? We can solve this question by understanding that these three values, essentially speaking, 2a should be equal to the third tier difference, 3a plus b should be equal to the second tier, and a plus b plus c should be equal to the principal term. So if you were to calculate it this way, 2a equals 2, so the value of a becomes 2 over 2, which is basically positive 1, right? Okay, we have calculated this part. Then what are we supposed to do? If we have the value of a, let's find the value of b. 3 into 1 plus b equals 5. B equals 5 minus 3. B equals positive 2. Now let's find the value of c. Uh, we know that a plus b plus c equals 3. 1 plus 2 plus c equals 3. 3 plus c equals 3. So the value of c becomes 0. So we have an square plus bn plus c, and the value of a is 1, n square plus 2n, and c is 0, so you don't have to write it. So what do we have as a what do we have as an answer? N square plus 2. All right, n square plus 2n. That's going to be your answer. Write this down so that we can move forward. Okay. Find a general rule for t. Test your general rule. Okay, let's just test it and verify it at the same time. So if I consider the value of n as 2, so I have 2 square plus 2 times 2, which is 4 plus 4, which is 8. So this is the testing part, and the verification part. If n equals to, let's say, 5. So 5 square plus 2 multiplied by 5, which becomes 25 plus 10, which becomes 35. So here we go. This is our answer. Prove to us. Can I erase this answer above? The one that has been written here?
Yeah.
Okay. Now we have to justify. So let's justify this. Let's see how this could be done. First do this part and then tell me once you're done, because then I'll need your attention so that we can solve the justification part. Now, if you were to solve the part of justifying the value, I think justification was done with respect to t, if I'm not wrong. Yeah, justify a general rule for t. So our general rule for t was n square plus 2n. But how do we know that we are so sure? Let's try this out. Now, if you were to move upwards, we can see that. Wait a second. Yeah, the equation that was given to us for the vertical triangles being created was n multiplied by n plus 1 over 2. Okay, n multiplied by n plus 1 over 2 for these triangles. And let's bring it down, because this is going to help us solve our answer. Now think about this logically, that if the number of triangles above the line is numerically equal to the number of triangles below the line, aren't they going to have the same equations for each other? They will, right?
Yeah.
Yeah. So this is for the number of triangles above the line, this is for the number of triangles below the line, and the number of triangles that cross the line is going to be same as n, right? As we can see in this diagram. And all of this is equal to t. All of this is equal to t. Now, can I delete all of this? The one
Yeah.
below? Okay, to explain this part to you. So what do we essentially have to do? We have to remove the brackets and remove the fraction to see if this is equal to n square plus 2n. This is what we have to see. Is it actually equal to n square plus 2n? This is what we have to see. So n multiplied by n becomes n square, and n multiplied by 1 becomes n over 2 plus n square plus n over 2 plus n. Let's solve for this part first. Okay. Essentially, what are we going to do? We are supposed to do it in this way, that we will get rid of the fractions. So if we get rid of the fractions, what do we have as a result? N square over 2 plus n over 2 plus n square over 2 plus n over 2. I wrote them all individually. Let's leave plus n at the end. N square over 2 plus n square over 2. Let's take these square terms on one side and the non-square terms on the other side. All of them, they have a common denominator, and that is 2. So when we have a common denominator, and if that's 2, so essentially what happens when both of them multiply with each other, sorry, when both of them add with each other, these two, wait, when these two are going to add with each other, we get n square. And when these two are going to add with each other, we get n. And then we can substitute our additional n that we had. So isn't that going to become n square plus 2n? Which is essentially the same thing as n square plus 2n, the value that we had found for the